Hello again, Marvels. I'm back to demonstrate what a transformation looks like when we also now have a horizontal shift due to a factor of h here. So to begin this process, I'm again going to label the parts of the transformation I know. And in this example, I'm dealing with the parent function cosine x. So I'll start here. 4 is going to be my A term, my B term is 2, my H term is negative pi over 2, and my M is 1. Okay, from here, nothing else is really going to change about my normal solving strategy. So I'm going to figure out my map's characteristics. My midline is y equals 1. My amplitude in this example is 4. That means that my max is going to be 1 plus 4, which means my max is now 5. My minimum is 1 minus 4, which means the minimum is now negative 3. My period is still given by the equation 2 pi over b. My b value is 2, so when I plug that in, 2 pi over 2, and simplify that, I'm left with just pi. And then my scale is going to be the period divided by 4. So in this example, it's going to be pi over 4. All right. From here, I can now begin to draw my x and y axis. Because my scale is pi over 4, that means that every mark on the x-axis is going to be... Apparently they're testing the intercom right now. Every mark is going to be an additional pi over 4. So I can begin labeling pi over 4. This would be 2 pi over 4, but let's think about what that means. 2 pi over 4 is really simplified down to pi over 2, then 3 pi over 4, then the next one would be 4 pi over 4, but 4 pi over 4 can be simplified as just pi. And I can do the same in the negative direction. All right. Next, I am going to add in my midline. My midline is at 1. So I'm going to go ahead and add a dotted line across. And label that as midline. Going to add in the maximum, 2, 3, 4, 5. And the minimum is that going to be at negative 3. 1, 2, 3. All right, I'm ready to begin plotting some points. And up until this point, I have really ignored this h value. And that's because when we graph these transformations, you do not need to worry about the h value until the very end. All of these other factors affect kind of like where the midline will be and what kind of a vertical or horizontal compression is going to occur. And then very lastly, we can shift the graph left or right as the h term dictates. So if this were just to, again, ignore the h value, I know this is a cosine function. I know that my cosine function normally starts at the maximum value when x equals 0, and it's going to continue to do that because this isn't negative. If this had been negative, I would start my cosine at the minimum value on the y-axis when x equals 0, but because it's positive, it follows the normal pattern of what a cosine function looks like. So I know my first plotted point will be at the maximum. Then my scale is pi over 4, so at the next value it's going to come down to the midline, because once you're at the top, the only way you can go is down. Pi over 2 is going to fall to the minimum. 3 pi over 4 will be back at the midline, and pi will be back at the maximum, which makes sense, because again, check it, my period is pi, so the idea that this is going to be one complete cycle of this periodic function matches what I would predict. Okay, so next I can just go ahead and continue the pattern and complete it for another cycle. So at 5 pi over 4 will be at the midline, 3 pi over 2 at the minimum, 7 pi over 4 will be at the midline, and I'll go ahead and add in 2 pi just to continue and finish this cycle so I can have a complete period. Alright, now I could also continue this pattern in the negative direction, but before I get going too far, I just want to show that that is actually not what this question is asking. This question involves a shift, and we know that h is like horsing around, so even though it says minus h, and we tend to think on a number line of our negative values being moved to the left, because this value is horsing around, it's actually going to shift my graph to the right, and it's going to shift all these points by a value of pi over 2. So what I need to do now is take all of these points that I've already plotted and shift them over a distance of pi over 2. So the way that my scale is drawn, that means that each of these values is going to move over a distance of pi over 2, which is going to be 2 marks on my x-axis because the scale is pi over 4. So to get a distance of pi over 2, it'll have to be 2, a distance of 2 to the right. So I'm going to take each of these points and move them 1, 2 to the right. It will be my new point. Pi over 4, move 2 to the right. Pi over 2, move 2 to the right. 3 pi over 4 will move 2 to the right. So we see some of these are doubling. Pi has to move 2 to the right. And when I draw this new, it's going to follow the same shape. I'm going to do it in a dotted line just to show the difference. But my very last step now was to shift the entire function over by a distance of pi over 2. And the last one, so this went here, this went here, this moved here, this shifted here, this point shifted here, and I'm going to shift, next I would shift this point here, and 3 pi over 2 is going to move to 2 pi, and I can continue down. I can also continue this pattern now into the negative direction, so I know that my next point would, if this is going to come back down following the same pattern, because the scale hasn't changed, it's just it was the entire graph was shifted to the right. It's going to still pass through pi over 4, and then at 0 it's actually going to be at the minimum value before it comes back up. Sorry, didn't mean to do that. And I'm giving myself a little bit of a roadmap for the rest of the negative portion of this graph. Okay, and so actually my dotted line is the line that I want. And if I had a separate color with me right now, I would be using that one instead. But what I want to drive home is when we introduce the h term in the coming days, It is solved the exact same way and plotted the same way, only you have to shift it at the end by whatever value you were instructed to do. So, thanks for watching, and come to class with any questions that you might have.